Let's find the inverse of this function. Okay, so first of all, let's do the reversal. I'm going to change this f of x to the variable y. That's what we're used to seeing. So I'm going to go over here and write y equals 4 minus x over 2x minus 5. Okay, so now I'm going to begin the reversal process, and that involves solving for x. So really, when I find the inverse, I need to solve for the other variable. So I'm going to solve for x. Again, usually what it's taught is first switch the variables and then solve for y. It doesn't really matter. The reason I'm doing it this way is so you can see that this was y is a function of x, and now we're reversing everything again. So now x is going to be a function of y. So what I'm going to do first is subtract 4 from both sides. So and again, I get y minus 4. These subtract. 4 minus 4 is 0. And I get the following. Next thing, again, the variable x is trapped on the denominator, so I need to bring it to the numerator. The only way I could do that for this fractional equation is to multiply both sides by 2x, so minus 5. So I'm going to multiply x minus 5, this side by 2x minus 5. So again, we got these two that really become 1. And now here I'm going to have to distribute. Why do I want to distribute? Because I'm trying to solve for x. X is trapped here. How do I get it out? It's by distributing. Or now you're saying, well, why can't you just divide by y minus 4? Then when that release, yes, but then I'm dealing with this other variable here. There's several ways of doing this. Let me first write down what the result of this is. Could I do it a different way? Yes, I could, without having to distribute. Again, thinking like a chess game. One thing I could do, let's try dividing this by y and see what would happen. So I got y minus 4, 2x minus 5 equals negative x, and divide both sides by y minus 4. Let's say I do that. Why not? Okay, so now these cancel, and what I'm left with is 2x minus 5 equals negative x over y minus 4. So again, what I'm trying to do is solve for x. And you see that doesn't get me anywhere, right? It doesn't, it's not, I need to put the x on both sides and then solve for x. X has to be alone. So that doesn't do anything for me. And that's why this is not a good strategy. That's not going to work. So I am going to have to distribute here. So this does not work. It's not going to release what I need, which is get x by itself. Because, well, what if I divide by 2? If I did that, I'm back to where I'm going. So the reason some people like to divide here both sides, this doesn't work. So that is out. So let's kind of continue then. So here I am. I need to distribute all this. Distribute. So this times y times 2x, y times negative 5, negative 4 times 2x, and negative 4 times 5 is positive 20, and that's all equal to negative x on this side. Okay, so now that it's here, I start getting everything that has an x variable to the same side because I'm solving for x. So how do I want to do this? I guess what I'll do is I'm going to, this has an x, this has an x. Let me get everything else to one side that doesn't have an x and bring that to the other side. So maybe what I'll do is I'll subtract this from both sides, subtract or add a x from both sides. So I'm going to leave this one alone, that alone, and this one's staying right where it's at, but I'm going to subtract this from both sides, the y2x. So I'm going to write it this way. Then I'm going to add 8x to both sides, and I get that. Okay, so these two do add up to combining like terms now. Negative x plus 8x gives me positive 7x minus 2xy. And again, I'm trying to solve for x, but I cannot say 7 plus negative 2 because I have this y here. They're not like terms. I can't do that. So what I'm going to have to do is factor out the x. Like so. Okay. And now that I've done that, I'm going to divide both sides by 7 minus 2y. And there, I've done it. I've solved for x. So the inverse function can be written like so. You don't like that, we can switch now, make this x and make that the sorry, make that x, yes, and change everything to x if you prefer to do it that way. But I've, in a sense, I have found the inverse function. And again, where right now what we have is f inverse of y is equal to x. That's what this whole thing represents, x, and that's what it's saying right here. But it's also the inverse function. Okay. All right, so we've done it. We find x, and now we're saying, hey, what is the domain of f of x? Well, if I'm looking for the domain of f of x, I need to look at this function right here. I can see this is just a fraction, and remember, this numerator, its domain is all real numbers. It's just you can put anything you want here. The denominator is also all real numbers. You can put anything you want here. There's one problem though. You cannot divide by 0. That's the only catch. So if you want to find the domain of x, normally you can enter anything except for the one thing that makes it 0. So the question is 2x minus 5 equals 0. What is x? What causes that to be x? So I'm going to add 5 to both sides. Divide by 2. And I see that if x equals 5 halves, then all of a sudden the denominator becomes 0 and you cannot divide by 0. Okay, so again, that is the problem. So what we're saying here really is that f of 5 over 4/2 is undefined because you cannot divide by 0. So what is the domain? Domain of f of x is start at negative infinity, go to 5 halves, union 5 halves, all the way to infinity. And there is my domain. What is the range of this? Of same function? Well, remember, the range of this function is the domain of the inverse. So if I want to find the range of f of x, is the domain of f inverse of y. So what's the domain of f inverse of y? I notice by not switching the x and the y, it makes sense if I'm looking for the range, it's going to be expressed as y's because that's the range of this function is in y. So again, that's why I do not prefer making this little switch. But again, now let's say it's another fraction, so same scenario. What causes this denominator to equal 0? So we'll set this equal to 0. I'll add 2y to both sides. Divide by 2. And there we got it. What we have is that at 7 halves, f inverse of y is not defined. So what do we do? So now we're going to say, so range of f of x is, again, start from negative infinity, and we just cannot include 7 halves. And there we have it. That's the range of f of x.